This is the second part of my video series on forces, and this has three parts in its own. We talked about Newton's first law, the law of inertia, the second law, which is force equals mass times acceleration, force causing acceleration, and now we're going to take a look at net force. We're going to look a little bit more complicated. When there's more than one force, how does that create a net force that causes acceleration? So just a reminder, F net equals ma. This is the net force that we figure out after all the forces are taken into account. Causes an acceleration based on the object's inertia or mass, which is directly related to inertia. And we're concerned with the forces acting on one object here. This is important. This is a real differentiator between this section and the Newton's third law. Third law, we're going to deal with one force creating another force, equal and opposite forces on two separate objects. So let's take a look at net force causing acceleration, F equals ma, with three different scenarios. The first scenario, you have 6 newtons and 12 newtons. Let's go ahead and just take a look at this. And if we have 12 newtons to the right and 6 newtons to the left, we'll go ahead and say right is positive, so plus 12 newtons. And we're going to go ahead and say that the left is negative, so we're going to add vectors. Once again, we're adding, but it happens to be a negative number. Most of you would probably just say 12 newtons minus 6 equals and be done with it. But I wanted to show you that we are adding vectors. It just happens to be the direction is negative, so we're going to be adding a positive to a negative. And the answer is going to end up being, either way you do it, it's going to be plus 6 newtons. And that plus has to come back and become a direction. In this case, it's going to be 6 newtons to the right or east. Let's go ahead and say right, since I just have a arrow that way. So now, once you have the 6 newtons right, now we're ready to go ahead. This is our net force. So neither of these forces alone cause acceleration, but the net force, F net, here is 6 newtons to the right. And we have a mass of 2 kilograms. And to solve for acceleration, we are going to go F net equals mass times acceleration. I just left off the net for the sake of doing the calculation. Acceleration equals force over mass. The force was 6 newtons, the mass was 2 kilograms, and therefore our acceleration would have been 3 meters per second squared. So simple enough, let's take a look at another example. This one's even easier. Here we have a net force of -6 plus another negative 12 here. And so you can say they're both the same direction, to say they're 18 to the left, or mathematically, if it was more complicated, it'd be more important to do, I was kind of sloppy, -6 plus a -12. And so it's really -6 minus 12, or -18 newtons. And that negative was to the left. So 18 newtons left was our net force. And we have a mass, so let's go ahead and just write it up here. F net equals 18 newtons. The mass is 2 kilograms still, same object as from before. A equals question mark, and F equals ma is the main equation. A equals F over m. F is 18, and m is 2, and therefore our acceleration is going to be 9 meters per second squared. So this is something that if it was a longer problem, we may have to use in the second part of the problem. Okay, and now we get into a little more complicated. Now we have no longer one-dimensional motion. So in order to deal with these, you have to put these vectors together, but you're going to put them together head to tail. I'm going to draw an origin dot, and it doesn't really matter which one you use first. I'm going to go ahead and draw this 12 newtons first, and I have to put the 6 newtons head to tail with it. Once again, it's like a direction. Wherever this one ends off, the other one begins. And then I'm going to draw the overall resultant. And this resultant is going to be my overall magnitude. So when I find out what this is going to be how many newtons of force, but I'm also going to have to figure out angle in this case. So to figure out the hypotenuse, C equals square root of a squared plus b squared. And in this case, a squared was 6 squared plus b squared, which was 12 squared, equals. And so we get 6 squared equals plus 12 squared equals, take the square root of that answer, and you get 13.4 newtons. And then we want to figure out what the angle is, because this isn't alone, this is the magnitude of it. But we want to find the direction too, and that's going to be inverse tangent of opposite over adjacent. So let's analyze this triangle. This is the opposite, and this is our adjacent. So to find the angle, angle equals inverse tangent of opposite, which was 6, and adjacent, which was 12. So inverse tangent of 6 divided by 12 equals, and you get, make sure you're in degrees, not radians. My calculator was in degrees. Let's try that again. So now I'm in the right mode. We're going to go take the inverse tangent of 6 divided by 12, and in this case we get, now that's a little bit better, 26 point, let's go ahead and say 6 degrees. So my final answer right here is that my final answer for the force, the net force here, is going to be 13.4 newtons and 26.6 degrees. And to describe this, let's go ahead. I'm just going to go ahead and call this north and this west for the sake of describing this. So 26.6 degrees to the north of west. So to the north of west. And now we want to figure out our overall acceleration. And to find acceleration, so our net force is 13.4 newtons, 26.6 degrees north of west. All we're going to do is we're going to tag along. All this stuff is going to tag to the end of my answer in a few seconds. Let's go ahead and take our mass equals 2 kilograms. Our acceleration, let's go ahead and find out that acceleration. So F net, or F equals ma. F equals ma is much simpler, but that's what we're dealing with is the net force. And A equals F net, which is F, I'm just going to leave out the net again, over M. And so that equals a force of 13.4 divided by 2. And once we get that answer, 13.4 divided by 2, I get 6.7 meters per second squared. And I'm just going to tag on everything from up here. It's just going to tag on to the end of this. 26.6 degrees north of west. The key here to understand is the direction of the net force is going to be the direction of the acceleration. And so once we used our numbers, we tagged on that direction at the very end. So this is the end of my first section. In the next section, we're going to talk about the rule of ones and dealing with ratios.